So let's begin our discussion of stoichiometry examples by using something, a reaction that we've seen in lab already. It's the reaction of magnesium with oxygen to produce magnesium oxide. So if we look at this, this is our given, grams of magnesium oxide, and what I've done is I've tried to set up a couple of different wanteds here. The first wanted is how many grams of oxygen. Okay, so two different problems. And the next one is how many grams of magnesium oxide. So we're going to work this in two different methods here. For any type of word problem that we have, we're going to need a balanced chemical reaction. So we know that the reaction for this is magnesium reacts with, and don't forget, oxygen is a diatomic element, so it's going to be O2. And it tells us that we're going to produce Mg magnesium oxide. Mg is a 2+ charge. Oxygen is a 2- charge. When we crisscross those, or when we balance the charges, it comes out to a 1-to-1 ratio. And so we've got 1 magnesium oxide, 1 magnesium. Notice that there are 2 oxygen on the left. We're going to need a 2 in front of here to balance. That gives me 2 magnesium. And so we have a 2-to-1. I'm going to go ahead and put the 1 coefficient in there. Allow me to erase the charges, because once it crisscross we have no charges there, 0 charge, and it would be solid magnesium, gaseous oxygen, and solid magnesium oxide. In our first problem, we know that our given is 5 grams of magnesium. Our wanted is grams of O2 that are needed to react with that. So we're going to begin with our given, 5 grams of magnesium. And if you recall the mole map, our first step is to change grams of our given to moles of given. Well, setting up our stoichiometric ratios here, I want to change to moles of magnesium, so I'm going to put moles of magnesium on top. And looking at the periodic table, I know that the molar mass of magnesium is 24.31 grams of magnesium. If I were to stop here, I would have moles of magnesium. And some students like to do that. They like to go from grams to moles, get an answer, and then do a second problem. I'm going to run our conversions all the way across. But what I will show is that if I were to get an answer at this point in time, it would come out to 0.206 moles of magnesium. I'm going to continue to run the conversion factors across here. Now I've got moles of magnesium on top, so I'm going to want moles of magnesium on the bottom. And I know that I'm going to have to convert that to my wanted, so I'm going to put moles of oxygen on top. This becomes our mole bridge that we spoke about earlier when talking about the mole map part 2. Well, where do we get numbers to put in here? Looking at our balanced chemical equation, I know that I have 2 moles of magnesium for every 1 mole of oxygen. And so that's where we get numbers. I'm going to make this 1 mole of oxygen from my balanced chemical equation. To 2 moles of magnesium. And that's why I don't use reactants and products when I'm talking about. I use given and wanted. If I were to stop here, my answer would be in moles of oxygen. So if I did the math, I would have converted this to 0.103 moles of oxygen. So right now I could know that 0.206 moles of magnesium is the same thing as 0.103. And that makes sense because in the balanced chemical equation it's a 2-to-1 ratio, and I now have a 2-to-1 mole ratio. But let's continue because the question asks for grams of oxygen. And so continuing our conversions, I see that moles of oxygen is on top, so I'm going to want moles of oxygen on the bottom, and I'm going to need to change that to grams of oxygen on top. A lot of students want to put the coefficients back in here, and it just happens that the 1 mole of oxygen matches this. This is always 1 mole. Well, how much does 1 mole of oxygen weigh? 1 mole of oxygen, since it is O2, weighs 32.00 grams of O2. At this point in time, I tell students to multiply all the way across the top and get an answer, multiply all the way across the bottom and get an answer, and then divide. Doing the math on this, if you were to do that process, would come out to 3.30 grams of oxygen would be needed to react with 5 grams of magnesium. Looking at the conversion factors to make sure we have the right answer, grams of magnesium cancels, moles of magnesium cancels, moles of oxygen cancel with moles of oxygen, and we're left with grams of oxygen, which matches our wanted.